So let's trace through some code that throws around a lot of references. And this example here doesn't lean so heavily on scope. We can see there's lots of references, and of course it's doing the usual cruel trick where every variable in the program has the same name. So I'm going to trace through it. We're going to start, of course, by making up our box for main. And in main, I'm going to create, right off the bat, I'm going to create three variables, A, B, and C. And then I get to line number 20. So I've created my three variables. I need to give one of them a name. I get to line 20 and I see C equals FAB. Well, of course, first law of assignment statements, let's just get rid of that C. Let's work on the function call. So I'm going to add F to my diagram. There it is. And then I'm going to keep an eye on what the argument types of F are. So now, because we have references that could be used, I should be careful to observe when I'm taking an argument by reference and when I'm not. So here I've got A, which is a reference, so I'm going to color that in. And B, which is not. And if I miss this, I could be in for some real trouble because obviously I could end up modifying something in main when I'm not supposed to. So what gets passed in as the first argument is the thing from main. And so it turns out that A in this context actually is the A in main. What gets passed in as the second argument to F will be a copy. So it'll be a copy of the number 116. All right, I think I have everything set up so I can actually begin executing F. Okay, so the first thing F does is set A to 6. Well, I go looking for A. Well, there's A, so here it is. In the scope of F, A actually is this other thing from main. So I set this to be 6. And then on line 3, B equals 10. Well, in the scope for F, B is that. So I modify this to be 10. And then I print some output. So F, and I print out the value of A, which in the context of F is 6, and the value of B, which is 10. None of that should be too surprising to us because we just set those two things. On line 5, I compute A plus B and then return that. I'm not returning a reference, so I just return a copy. So A is 6, B is 10. Of course, that means that the value I am returning is the value 16. I go make a note of that down in main where I have made the call. So that's here. And then I clean everything up. So I destroy the scope for F. I make sure that it is gone because, of course, there are names in F that I'm using elsewhere in the program that I do not want to cause any confusion later. And now I'm back on line number 20 of main, and I can uncover the left-hand side of the assignment where I wrote C equals. So I take the value 16 and I assign that to C. Then I get to line 22. Line 22 says call a function g. And this is an especially dirty trick because I'm passing in B, C, and A, and I'm taking them as A, B, and C. But I think we can manage. So there's my function g. G also has three variables A, B, and C, but we'll notice that C is by value and the other two are by reference. So here's A, here's B, and here's C. And they're all ints, except that A and B are passed by reference, and therefore they aren't real variables. They're just new names for existing stuff elsewhere. Whereas C is a real variable in the scope of G. So what am I passing in? Okay, well, the value of B is going to be, or sorry, I shouldn't say value. The first argument I'm passing in is what's called B in main, and it's being passed by reference, and that means that the value called A in G actually is this variable B in main. The second thing I'm passing in is C in main, and that means that the thing in G that is called B is going to, the second argument is this C in main. This is already a nightmare, but once I get the diagram set up, I won't have to worry about what the names are. I just have to work inside of the scope. And then finally, the third thing passed in is the value of A. Because it's being passed in by value, it's just a copy. The value of A is 6, and so I pass in the value 6. And now I'm ready to execute G. Mercifully, there's no return value, so all I have to do is make it through G. So I get inside of G. I'm now on line 9. B equals A. Okay, when we have this tangly business happening here, we should make sure to obey the first law of assignment statements, even on very simple assignment statements. So what is the value of A? In the context of G, that would be 116. So of course A is this thing in main, but who cares what it was called in main? I only care what it's called in G. Okay, so I get rid of that. I uncover the left-hand side of the assignment, take the value 116, and assign that to the thing in G called B. Okay, so the thing in G called B is this, which happens to be this thing in main. I set that to be 116. I get down to line number 10. I cover the left-hand side. I get the value of C in the function G. Well, that's just 6. All right, I uncover the left-hand side, and I assign that to the thing in G that's called A. So that's going to end up getting assigned the value 6. And then I get down to line number 11, and I set C to 0. This is one I think I don't need the first law of assignment statements for. There we go. And then on line 12, I generate some output, G, and I print out A, B, and C. So inside of G, A has got the value 6, B has the value 116, and C has the value 0. And then G ends, so I get to destroy this scope. Fortunately, I was getting pretty confused. And that brings me back to main. I'm now on line number 24. I'm doing so much erasing that my drawing program is actually falling behind. I'm now on line number 24. I print out the word end, and then I just dump out the values of all the variables I have in main. So let's see. The value of A in main is 6. The value of B in main is 6. The value of C in main is 116. And as usual, if I can make it all the way to the end, usually that very last print statement is pretty easy because I just have to print out all that I have left on my diagram.